Thank you for watching Knowledge Academy. Okay, let's start chain rule of function of several variable. So what is exactly the chain rule and why do we use them and what is the benefit for using the chain rule? So first thing first, chain rule is just like name chain. So in chain rule, they have like a link, you're making links and those links are actually helping you go from one end to the other end, right? How are we gonna see? And a good part is that you, if you want to go from here to there, you take little steps, little steps. So in order to accomplish big, in order to accomplish from point A to B, you're gonna go from A to here, step one, then step two, then step three, then step four. Okay. Now all these things like one, two, three, four, I make four link, and these four links are four different variables, right? Maybe it's X, maybe it's Y, maybe it's Z, maybe it's W. And if you are talking about simple one, I have only two link, right? I can go from one end to another one, but I have two link, one and two. So I need to do one step, another step, and then put together these steps. Another thing we learn, these steps are really a partial derivative. Same thing, this step is also a partial derivative. So long story short, if you want to say what is the chain rule is a way you can go from finding a change in the function, a big change in the function, by analyzing or making small change based on different variables, one variable at a time. So a function have, right? Function have two variables and you want to look at the change in fx and y. What you're going to do, you look at the change by x, right, plus change by delta y, and that is my goal. That is the chain rule. That is a chain rule, and it's a chain rule, but originally really it's using partial derivative to do the job. Okay, we're gonna start for one variable function, then two variable function, and then pretty much that's what we're gonna be stop there. So we are going that far. So look at what is the theorem of the chain rule. So let's talk about the chain rule theorem. The one I just showed you so far is just a graphical representation, how graphically you can tell the chain rule. Chain rule, right? And I have one independent variable. Right, one independent variable. And when I say one independent variable, what does that mean? Long time ago, we discuss about parametric equation, and we says, if f is a function of x, right, and maybe y, f is a function of x, y, and you're writing some function x squared plus 3y plus 2. What I'm going to be doing, I'm going to take this x is x equals to something in t, so t squared minus 1, y equals to t. I'm going to take this, substitute this value into the function. So you can see here, function depends on x and y, x depends on t, y depends on t, but t depends on no one. So when the final function does not depend on no one, that is my independent function. This t is my independent function. Or this is my independent function or my independent variable. Yeah, independent variable. So I'm going to write this whole thing over here in a little bit different way. So take a look. Let w equals is a function of x and y, where f is a differentiable function of x and y. If x is a function of a function of t, right, and y is a function of another variable, but is still a function of t, where g and h are differentiable function, with g and h are differentiable function, just like I wrote a few minutes ago. Then I'm going to be writing like this. Then w is a differentiable function of t. W is a differentiable function right? And how can I write mathematically? I want this. Look at the sign. dw or derivative w with respect to t. Pay attention on sign. Remember when I write this and when I write this, it means typically full derivative, only one dependent variable. Typically full derivative. This means partial. It means partially there is something else going on in the function too. This one is a full-fledged derivative. So I want my w change with respect to t full, not partial, full. And I'm going to be writing like this. Since my w is a function of both x and y, right? I'm writing this. It's right here, x and y. So I'm going to be writing this function. It's going to be look like partial derivative of w with respect to partial derivative of x dot partial derivative of x with respect to partial derivative of t. Now, since this is not a partial derivative because my x, remember I just showed you a few minutes ago, x is dependent on t, and t is the last guy in the chain. So I can change this guy and maybe I can write like this. I can write full-fledged x because dx dt, because they both are dependent. The t is the last guy in the chain. There is nothing you can split further in the chain. Plus the other side is w with respect to y, multiply this dot mean multiply, and then dy over dt. If I want to draw this thing graphically, I'm going to be drawing, and then you have to draw first graphically, and that's how you're going to be writing. I have a function w. W depends on x, w depends on y, right here. W depends on x, w depends on y. You draw this thing. So x and y. So I'm going to write here. I'm going to write here. X depends on who? T. Y depends on who? T. Does T depend further on anything? No. So what I'm going to do, I'm going to be writing little things over here. I'm going to write here dw over dx, then delta dw, which is partial derivative with respect to y. And here I'm going to be writing, if I'm going to go from here to there from t, I'm going to be writing like this over this and dy over dt. If I want to go from, I want to go from here all the way down to t, right? This is what I want. This is what I want. This is my want. And the rest of the thing in the center is this is what I got. So remember, I want to go from A point to B point, just I show you graphically, which is from here to there. But in the middle, I have a little chain. I have to take care of them. And these chains are this chain, then this chain, then this chain. So I'm gonna multiply these two, and then add these two. Make sure you draw like that. You add the side by side, and one side you multiply. So you multiply, go from here on the top. Delta W over delta X right here, times dx over dt right here, plus the dw over dy right here, plus this guy over here. Okay. I'm going to be doing pretty much same thing into a function of two variables. Like x is not only depends on t, x depends on s and t, right? Just think about it, just like your course grade, right? Your course grade, you have total GPA in your college, right? GPA. Your GPA have course number 1, course number 2, course number 3, right? But every course have a bunch of assignment. Assignment number 1, assignment number 2, assignment number 3, assignment number 4. So every assignment is participating your total GPA. How are you gonna do it? Exactly the same way. It's just a little bit more math, right? Or algebra. If you're not talking about variable thing, you're talking about fixed thing. So algebra is gonna take care of that. But if you are talking about variable quantity like functions, then you have to deal with calculus. Let's take a look on an example. How does it go? Let's take a look at another problem. So let w equals to x squared y minus y squared, where x equals to sine t and y equals to e t. You can see both an x and y are actually ended up on t. There is nothing and going on forward, moving forward after t. T is basically a dead end, right? When t equals to 0. See, this is what you need to find out at this value of t. Okay. So what I'm going to do, I'm going to be just drawing real quick here the function. I have w belongs to x, y, then t, then t. I have a t delta w over delta x. Here I have a delta w over delta y. And here I have a dy over dt. Here I have a dx over dt. If I want to write this thing, I'm going to write the chain rule. I'm going to write like this. Oops, I should not be writing the partial derivative. It should be full derivative of dw over dt. And I'm going to be writing here so multiply these two, then plus multiply these two. So the multiplier, the last one is going to be and it should be multiplied here. If you want to more elaborate this, can you put in the parentheses so you know this is one side and this is another side, right? And if I want to do this thing by using the derivative, so dw over dx, so dw over dx, if I want to do it here, I can maybe take this one, dw over dx, and take with respect to x. So it's going to be 2x, right? 2xy, this is my first function. I'm going to write here. Then I have dx over dt, so x is here, is going to be cos t, right? Plus this guy here, this guy here. So dw over dy is going to come here, is going to be x squared minus 2y, right? If you come here, 2y. And if I do the last part here, it is going to be et, or exponential t, which is right here. I can substitute the value, right? I can substitute the value and basically elaborate further. If I want to, I can multiply the things to substitute. Now in this problem, there's a problem, further problem going on is I cannot put t equals to 0 because in this function I have x and y. So what I'm going to do, I'm going to rid of this x and y and replace with t function, which is given in the question. So all I can do, maybe I can write like this, 2, then sine t, this is the value of x, then et, then cos t, then plus sine square t, which is given in the function. So I replace this x value given in the sine t minus 2et and then et. You can further simplify this and then do, I think everything will be gone, right? Everything will be disappeared except this minus 2, right? This whole thing will be 0 and this thing will be 0 when you substitute t. Sine t is 0, minus et is 1 and 1, so it's going to be minus 2 is the answer for this whole function. Okay, and just so you know, if you want, so chain rule is the shortcut. So chain rule is a shortcut. When I say shortcut means, you see, you're solving this little thing, then little thing, then little thing, then little thing. You're solving little things. If you really want, want to solve this function or this equation, you really doesn't need a chain rule. I mean, you don't have to use chain rule. You can use the longer method, and longer method is that I'm going to take w equals to, substitute the value here with this. So it's going to be sine t square, and then y is going to be et minus et square, and then you can take dw over dt. Yeah, you can solve this, right? And it's going to be pretty much give you the same answer. It's just a little bit more complicated derivative. Okay. Okay. Take a look at another example. Let's take a look at another problem. If w equals to x squared plus 5y and x equals to 2t, y equals to t. My independent variable is who? My independent variable is t, because t is a dead end, right? T is independent. Anything else dependent on t. So I'm going to be writing like this. I have two options. I'm going to go with chain rule. Chain rule again says make sure you keep drawing this tree. At least you're familiar with this and very comfortably draw this without any hesitation, because this is a tree you're going to be drawing in most of the question to avoid any kind of mistake, right? So I'm going to multiply these two and then that two. So I'm going to be writing my solution here, and by chain rule, I'm going to be writing dw over dt should be equals to partial derivative of w with respect to x dot derivative of x with respect to t plus partial derivative of w with respect to y dot dy over dt. Okay. Now everything is pretty much given. All I can do is just substitute. So dw over dx, this is my thing. So I'm going to take this equation and take the derivative. So the first one, dw over dx, going to be 2x dx over dy, dx over dt, which is here, is going to be only 2, and plus 5 and then 1, right? Dt is 1 and this is 5. Can I solve this further? Yeah, I think I can do that. Plus 5, right? And if I want to substitute the value of something is given for t, I can substitute, but in this question I did not give you the t value, so you have to leave it here. That's my answer, right? But if the function the x value and y value is given, you can substitute here to finding the exact number, the one I give it to you. Okay, sometimes we do it, sometimes we don't. Let's take a look at another problem. W equals to x sine y and x equals to ex et and y equals to pi minus t, right? And when t equals to 0. So this function has pretty much everything you can imagine. And let's start it. Since we already know the formula, I'm not gonna write it, just directly writing the formula. And dw over dt must be equals to partial derivative of w with respect to x dot dx over dt plus partial derivative of w with respect to y dot dy over dt. I'm going to substitute the value given here. So dw and w is given here. Let's do the w derivative with respect to x is going to be sine y. Let me just do it here. Sine y. So we know how we solve it side by side. And inside the parentheses, I'm going to be writing exponent t dot, should be plus dy over dw over dy. So dw is here, dy is here. The answer would be x cos y, and when you take dy over dt, it's going to be minus 1. Okay. I want to solve dw over dt, but I see a bunch of strange variable here, which is x and y and this y. I want to rid them off. It's much easier. I can just substitute the value which is given here for x and y. I can substitute them. So I'm going to substitute them because I want my equation to be in the form of t, so I can substitute this t, right? I have another way. I can take this t and substitute here, here and here, and finding x and y value and then substitute here. But I don't want to deal with, it's pretty much the same thing. All I'm doing is just a different way of doing things. So I'm going to rid of this y and x. Okay, sine y minus t exponent t plus I want to rid of the x. So it's going to be et dot cos pi minus t, and yeah, that's pretty much what we got here. This minus sign is going to come out. So I think this should be minus here. Because this minus sign is going to come out, there should be minus here. If I want, I can just further simplify this by using the formulas. And what I can do, maybe I can just substitute the value. Et sine t plus et cos t. And if I substitute the value of t equals to 0, it's going to be 1. Sine 0 is 0 plus 1 and 1. So 1 and 1, answer is 1. So really what does that telling me in real life is dw over dt have a ratio of 1. It means if you change t by 3 units, w is changing 3 units, right? If it's a ratio between the two is same, it's just like Pythagoras theorem. So really is not Pythagoras theorem, is a right angle triangle with two equivalent sides. If you go here, which is x, you can go here as much as y. So if you have a graph like this, which is 45 degree, let's suppose this is 45 degree, and you can take any point between here to there. And if you want to go from here to there, you say I want dy over dx, right? So you can go here and you can go here. Whatever side, whatever is there, I don't know, 1, 2, 3 should be whatever is here, 1, 2, 3. So the ratio between dy over dx equals to 1 here, really. And that is that's exactly what telling me. Both have the ratio 1:1. This is basically some extra work. It's not belonging to this problem. It's just a elaboration of this problem telling us something. Is going to be minus t yeah, maybe it's minus t. Right, this minus sign is going to come out here. Let me go to the difficult part of this. And since we are a little bit familiar with chain rule, we're going to go and then do the two things, like two variable method. And what is a two variable method is, I'm going to go and then talk about that. If I go back this slide, right here, my function is x depends on t, y depends on t. All I can do right now is x is not only depends on t, it depends on t and maybe s. Y is also depends on t and s. So I have two variables. So really I need to add another variable we call s, another variable we call s, and then do the same method. Okay, let's do it two variable one. Let's take a look another problem. When I say two independent variable means it's not going to change anything. W is function of x and y. W is a function of x and y. Now these x and y, they are not the function of t anymore. They are the function of t and s. Maybe here t and here is s. So I'm going to do the pretty much same thing. I'm going to write it like this. You are going from w to y, so dw over dy. You're going from w to x, you're writing dw over dx. But you're going from x to t, so this time you're going to be writing all partial derivatives. See, because they have all, these are not the last one, they are separated. So there is nobody's full derivative anymore. That's the bottom line. There is no more full derivative anymore. If I want to write here, this whole thing is going to be so it's going to be 2 . by dw over dt, it should be the same old one, the one we used to write. Oops. Okay. Okay, let's do a problem for this one and see how does it go. Let's take a look at another problem. Use a chain rule to find. Remember, you can also always use not chain rule. You can use any other rule like traditional way of calculating derivatives to find dw or ds and dw and dt for w equals to 2wx, and where I have x and y is given in the form of x and t. X is given usually x before given in the form of t, now is given in the form of t and s both, and y is given s over t. So you can pay attention here. I have both variable involved, guys. That's why it's two variable function. Okay. It's pretty straightforward, just like what we used to do it, just another variable involving. So I'm going to say is dw. Oops. Change the color. If I take dw over dx, so w is here, right here again, given. If I take with dx, it's going to be just 2y. And if I take with respect to dx over ds, right here, it's going to be 2s. And t's a constant at this point, so I'm going to write here. Here, t is considered as a constant, right? Because I'm taking with respect to s, so 2s. Plus, if I take the dw over dy, so dw over dy is going to be 2x, and dy over ds is going to be taking 1 over t. Right. Now I have a same problem. I have two problems here, a little bit like this t and this x. I doesn't like it. I want to rid them off because I want dw over ds. So only s should be there, not no one else, or maybe t should be there, right? So I want to rid them off to unnecessary variable. So what I'm going to do, I'm going to be just doing this. 2 s over t, then 2s plus 2s squared plus t squared 1 over t. Right. Maybe I can just simplify a little bit more if I can. It will be 4s squared over t plus 2s squared plus 2t squared over t. If I take the multiplier, the least common multiplier, LCM, between the two tt, and I can write here, maybe I can just add these two and this one. It's going to be 6s squared plus 2t squared. I don't think so you can do further much simplification, but if you want to take the common 2, you can take it, but I think it's good to go right now here. Maybe I can do the next part on the side by side, like here. So since I have eliminated this part, and I'm going to do the other side dw over dt, and I'm writing here, in this case t is constant, right? Other case s will be constant, and I want this. So let's take a look real quick. 2y, then 2t, then plus 2x from here, dw over dy, 2x, and minus s over t squared. This is the dy over dt. I'm going to do the same thing here. Let me just write here. Here is s is constant for this guy, t is constant for this partial derivative. I'm going to rid of this y and x just like I did earlier. S over t and 2t plus 2s squared plus t squared minus s over t squared. Okay. Then 4s minus, here the dt cancel. This minus is going to come out and come here to replace this plus with minus sign, and then 2s cubed plus 2s squared, 2st squared, okay, 2st squared divided by t squared. If I want, I can just do further simplification. 2s t squared minus 2s cubed plus 2s t squared. I can a little bit simplify further. I can. This is 2s t squared. So 4 minus 2 is going to be 2s t squared minus 2s cubed divided by t cubed. And this is my dw over dt. I don't think so I can go further this and that. This is pretty much my answer. Let's take a look at another problem. And what else? Dx. Here is the s is given in the form of s plus t and y equals to s minus t, right? I also want to give in the s and t value, s equals to 1 and y equals to, s equals to 1, t equals to 3. So really in this problem, I cannot give a variable answer. I have to give a numeric answer called definite answer, right? These are pretty much all the things are given. The way I'm writing it so we cannot confuse about terms here. So I'm going to write in dw over ds and dw over dt. So it's going to go by dw over dx plus times dx over dt. I'm going to do directly. Dw over dx is going to be 2x and dx over dt will be just 1. S is a constant here. Sorry, t is a constant here. T is a constant here and s is a constant here. this. Yeah, this is plus 2y and then 1. Here I have the same dilemma. I want to replace this x and y, so I'm going to substitute 2 x replaced by s plus t right here, and plus 2s minus t. If I'm going to simplify it, it's going to be 2s, 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 and then this t and t cancelling out, so I think it's going to be left 4s. Here, when I'm going to be solving this, it's going to be dw over dy, then dy times dy dt plus dw over dx times dx over dt. So I'm going to be writing, directly taking the dw over dx, and it's going to be 2x, and dx over dt, right here, dx over dt will be just 1 plus 2y, right, dw over dy, and dy over dt will be minus 1. Now, can I simplify that? Yes, I need to rid of this x and y because the given function is independent variable is s and t. So I have to be convert everything into this, into s and t form. This minus 1 is minus 2 is going to come out, so y equals to s minus t, and that's pretty much what we have here. Yeah. Okay, can I cancel something? So 4, I think this 2s and this s will be cancelling out, and it's going to be left plus 2, so it's going to be 4s, 40, sorry, 40. So s term will be gone and 40 left. I have two values. If I substitute the value, so let me write here one more time, dw over ds equals to, we substitute 4 and 1. If you multiply, the answer will be 4, and the other answer will be, 12. Okay, so this one is be 12, this one will be 4, and that's pretty much. Let's take a look another problem about chain rule. And chain rule have bunch of questions we did. Let's continue do some more problems for the chain rule. But we're going to be doing chain rule for two variable chain rule. It has two variable or two independent variable, t and s. Okay, so let's take a look in this problem. This problem, we need to find partial derivative of dw over ds and dw over dt using the appropriate chain rule. Okay. The question is given is, I have w is given in the form of y cubed minus 3x squared y, and x is given e to the power t, and y is given e to the power s. In other way around, e to the power t, and the other one is e to the power s. Okay. And also is given x equals to 1 and s equals to 1, and then t equals to pi by 2. S equals to t minus 1. S equals to minus 1 and t equals to 2. These are the values are given. Everything is written in a straight line, so you cannot mix and match. So let's start it. Since this is a dual variable. So we have to solve delta W and delta T separately. To separate, and I'm going to be doing is dW over dx and then dx over ds, in this case. And I'm going to be canceling out and we're going to get this one. So what I'm going to do directly substituting the values. So dW over dx equals to minus 6 xy, right? Then I'm going to taking with the dx over dt, and it's going to be e to the power s plus 3y squared. I'm taking the direct integral of this function. Really, I'm doing this. I go back here. Yeah, I'm just writing this dw over dx and dx over ds. Same thing, dw over dy and dy over ds. Here is going to be changing dw over dx and dx over dt. So the only difference here is ds and dt, since we have a dt here. Okay, let's go back. Yeah, here. And I'm going to writing, so this is my dw over dy and then dy over ds. So dy over ds will be pretty much 0 because dy doesn't have any dt term, so it's going to be 0. So this whole term will becomes 0, and I can write like this: minus 6 xy e to the power s. Since I have an x and y is given, I want to rid of this x and y substituting the values, so I'm going to write here. So it's going to be minus 6 e to the power s, then e to the power t, then e to the power s. So e to the power s, then e to the power t, then e to the power s. This one, the last one, as is. Since I have all the powers, bases are same, so power can be added. This s and this s can be adding to 2t, sorry, 2s minus 2s plus t, 2s plus t. So I'm going to be writing here 2s plus t. So this s and this s becomes 2s plus t. And that is my pretty much answer for dw over ds. I have to substitute the value of my given variable for s and t. I'll do it when I done the dw over dt. So let's do the dw over dt. It's going to be dw over dx and then dx over times dx over dt. So dw over dx is going to be minus 6xy then 0, because there is no term for ds over dt, right? So you can see here dx have no term of dt. So when you take the derivative of dx with respect to t, the answer will be 0 because there is no term. Everything will be constant here. Now I'm going to move in plus. Then dw over dy. So 3y squared minus 3x squared. And then dy over dt. So it's going to be as is e to the power t. I'm going to do pretty much same thing here. I'm gonna rid off this. But before than that, let me see, I can write something like that. 3y squared, so e to the power 2t, square means 2t, I just take up, and 3 to the power x squared, so x squared is es, so square will be e to s, right? E to s, and et is going to be coming et as is. If I further elaborate, I can write like this maybe e. Since 2t and t is going to be same, so bases are same, I can add the power. 2t plus t will be 3t minus 3 times e. Bases are same, I can add the power 2s plus t. Right? Now, this is my answer, but this is my answer given in the form of t and s. These are the two values are given. I need to substitute the value. So if I substitute the value, this is going to be the top one will be beta will be uh, minus 6, and everything will be becomes minus 1, minus 2. So e to the power 0 becomes 1, and I can write minus 6 as is. dw over dt, I want to substitute the value. So 3 to the power e 6, right? D is given 2. 2 times 3 will be 6 minus 3. Since s is minus 1, so s is minus 1, minus 2, minus 1 plus 2, minus 2 plus 2 will be e to the power 0, and e to the power 0 means 1. So I'm going to just write it like this. If you want further clarification or simplification, you can simplify it further. You can take this guy 1 minus e to the power 6 minus 1. You can write like this as well. And that is pretty much my value. Again, I cannot go any further simplification. Yeah. I'm going to do same kind of problem, dw over ds and dw over dt for another problem. Let's take a look at another problem. In this problem, my function w is given in the form of a trigonometric function. In the form of the trigonometric function, and my x is given as plus t, my y is given as minus t. The value of s is given to 0, the value of t is given pi by 2. Okay, everything is written separately, so we're not confused. Solution. Since this is a two separate one, I'm going to be taking this s, and then I'm going to be taking dw over d separately. This one will be, I'm going to take the dw over dx times dx over dt. So dw over dx means sine to the power cos theta. So cos theta will be 2x plus 3y. And derivative inside the angle with respect to x. So if I take the derivative of 2x plus 3y, the answer will be just 2. I can just write 2. I can write 2 here, or I can move the 2 on the previous one. Okay, maybe you can write 2 here. It's much easier to understand since this goes step by step, but I just moved the 2 in the beginning because it looks more appropriate. Plus, I'm going to do the again dw over dy this time. So it's going to be again cos 2x plus 3y, and I'm going to take the derivative of the angle with respect to dy, so answer will be 3. Okay. Since I have two of the same, I can just add them together. Both angles are same. You can see here this angle, cos 2x plus 3y, and then cos 2x plus 3y. It has a 2, it has a 3. I can add them and say it's 5. Yeah, because the same function, I can add them. I can say it's 5 cos 2x plus 3y. I also doesn't like x and y. I want to read them off and put it into the form of s and t. So I'm going to be writing here 5 cos 2, and x will be replaced by s plus t. So s plus t and plus 3 s minus t. Right. And if I'm going to be elaborating further, it's going to be simplified. I can write here 5 cos 2s plus 3s will be 5s, 2s, 3s will be 5s, and 2t minus 3t will be minus t. So that is pretty much what I got my answer, right? I need to substitute the value of s and t later. Okay, just leave it now. Continue the other part. And it's going to be dw over dy, dw over dx times dx over dt. So dw over dx is going to be just like this one, dw over ds. dw over dt is going to be do the same follow. So it's going to be 2 cos 2x plus 3y, right? And I'm going to be continue plus, and this time is going to be minus cos 2x plus 3y, right? Look like both have a same angle. I can add them together. When I add them together, 2 cos and minus 3 cos, it will be minus cos 2x plus 3y. Just like the other one on the preceding up step, we're gonna be just rid of x and y and putting in the form of s and t. X and y should be gone and s and t should be in. So what I'm gonna write here minus cos 2 x will be replaced by s plus t plus 3s minus t. And here is minus cos 2s plus 3s will be 5s and 2t minus 3t will be minus t. Okay, this is pretty much my answer for dw over dt. I'm going to substitute the value when s equals to 0 and then t equals to pi by 2. How these values are going to look like. So dw over ds is going to be look like everything here is going to be minus it's going to be 0, right? So because cos s becomes 0, so this whole term will be 0, right? This whole term will be 0. When you bring s 0, this whole term will be 0. T equals to pi by 2, which is pi by 2 is 90. Cos 90 is 0, so this whole term becomes 0. So the 5 times 0 will be 0. So this answer becomes 0. Okay, so I'm going to be writing here 0. Same thing if I want to write dw over dt here, look like pretty much same scenario. This 0 and then minus pi by 2. So this one is going to be 0. So look like both answer is 0. Okay. Now let's talk about another topic which is a little bit different than chain, but it's a part of the chain. It's a part of the chain. The new topic we're going to start, its name is implicit function theorem. Implicit function theorem. What does implicit mean really? Let's talk about the implicit first. Implicit means internal, or it's like unseparated. You cannot separate things which is implicit. It cannot be separate. Uh, so this is implicit means things cannot be separate. Function means function, and theorem means a logic to deal. So really, what is the implicit function? Implicit function theorem is a methodology. We can use it to solve a function which cannot be separate. So let's take a look into more detail. What are those? Let's talk about what is implicit. The definition is an implicit theorem or implicit function theorem is a theorem that is used for the differentiation of a function. For differentiation of a function that cannot be represented in a or in this form is not available like this. You cannot write them like this. For example, right? For example, I'm going to write here x squared plus y squared equals to 1. Basically, it's the equation of a circle. You cannot write like this because it's combined function. You cannot separate the x, separate the y. Okay? And I'm going to talk about that in a minute. And another function I can write here maybe just like this, for example. Another one I can just write in examples, x squared plus 3x y cubed plus y squared plus 39. I cannot separate them because the thing is, it's very hard for me, or pretty much impossible. I can make y separate and x separate and put it on the other side of the function. So I can write y equals the function of fx, just like I used to do it, and I can say is delta y over delta x over delta y. I cannot do that. This is not doable in these functions. So these are called implicit functions. Implicit means the implicit means how they combine like that, right? So how do you deal with that in these kind of functions? Let's look at the example for the first one. Let's take a look at another problem. So in implicit function, I'm going to say that consider a circle. I'm going to say it's problem for implicit function problems. Consider the equation of a circle having a radius 1. Use the implicit. You can solve them without implicit. It just take a lot of time and efforts. Use the implicit function. Just like you guys know, we call Pythagoras theorem. What is Pythagoras theorem? Pythagoras theorem is used to solve right angle triangle. But do you really need Pythagoras? Probably not. You can use trigonometric function to solve the triangles. It's just Pythagoras is making things much easier and quicker to solve. So implicit function is a shortcut. Simple as that. Implicit function or implicit, uh, you know, uh, function theorem is a shortcut to solving a function which is implicit. They are combined. They cannot be easily separated. Okay? And function theorem to find the formula for the slope of the tangent of any point in a given point, x and y on the circle. So really what they're asking, they're basically asking, they want the slope of a function. And it means, this is the equation. So first thing first, what I'm going to do, I'm going to write this equation in the form of function. So I'm going to make everything in one side. So I'm going to be writing like this. I'm going to bring the one on the other side. That is my function. And really is asking to calculate this. Fy dy over dx, and dy over dx can be written like this. The implicit function formula is, this one is going to be, technically is going to be dy over dx, right? It's going to be dy over dx. So I'm going to do the partial. So this is actually what it means, dy over dx. But this is not, I want this. This is my want. The implicit function is this guy going to be equal to, take the function and take the derivative with respect to x, and take the function and take the derivative with respect to y. If you take the reciprocal of those, right, you're going to take it back up, is going to be dy over dx, and df going to be cancelling out, and it's going to be dy over dx left over. Since we are taking, you see here, dy in the numerator, dx in the denominator. Since we are doing other way, we have a numerator x, denominator y. We have to put a minus sign. So really, if I want to write the function, every time you want a derivative, like dx, you're going to be writing like this. In the numerator, you're going to be writing whatever is not given. And then you're going to be writing the x on the denominator, in the numerator, not in the denominator. So it's going to be writing like this. X going to go in the numerator. There's a minus sign is going to come here, and then df over dy. And that's exactly what I'm going to write inside this red block or red box. That is my implicit function theorem. Yeah, I'm going to continue and complete this problem and see what is an answer. Okay. Here, my function is given. I already found this function right here. I already made my function in one side. So I'm going to be finding the function derivative with respect to x and function derivative with respect to y. So let's do the x first. X equals to, I'm going to be writing step by step, and the answer would be 2x plus 0 minus. That is my answer. So really, df over dx equals to 2x. That is my first. I'm on the second part, which is df over dy equals to, I can write like this. The function is 2x, so the function will be x squared. And if I take the derivative with respect to y, it's going to be 2y. Now here, I just want to take this equation number 1, equation number 2, and I can substitute into my implicit function theorem, and I can write minus 2x, 2y, 2 to cancel, and the function is where my function or my derivative is really slow, which is need to be determined in this case with minus sign. Find the derivative of a polynomial and the polynomial equation is given 2x squared minus 4y squared equals to 6 using the implicit function theorem. And I need to solve this by using the implicit function theorem. Okay. First thing first, I need to get my function. So I'm going to say is 2x squared minus 4y squared equals to 6. I'm going to bring the 6 on the other side. So I get my function straight. And my function would be equals to 2x squared minus 4y squared minus 6 equal to 0. And I can write in the form of function. Okay, this is my function. Now I want to write using the formula for the theorem. I'm going to be writing, I need to take the derivative of with respect to x equals to minus. Remember, this is x, so it's going to be going to the numerator. So it's going to be df over dx df over dy. Same thing if you're writing like this. Let's suppose you are calculating the dz, right, with respect to dz. So on the numerator is going to be going df over dz, and then df over dx or whatever the function is. I really doesn't know what function is going to be, but you're going to be, the denominator is going to be like that. Okay. Let's continue. So what I want to call this equation number 1, and I need to find out my df over dx, and I can write like this. So 2x squared minus 4y squared minus 6. If I take the derivative, the answer will be minus 8y. Well, minus 4x. Just a 4x. So I'm going to take it is going to be 4x and same thing if I take the derivative of function with respect to y is going to be this way, minus 4y squared minus 6. If I take the derivative is going to be minus 8y. I'm going to take both and substitute into equation 1, and it's going to be f prime x equals to minus, and I'm going to be substituting this minus, and minus from the function I'm going to be writing 4x divided by minus 8y. This minus minus becomes plus, and this 4 and becomes 2, so I'm going to writing x over 2y, and that is my derivative, right? That is my answer. You can see it's fairly simple. I did the complicated function solving, just take the derivative in really fast way. I don't have to put much efforts. Let's take a look another problem. In this problem, I'm going to be doing 2 ways this problem, or just writing the function. The function is given, I'm going to be doing implicit and without implicit. I'm going to be doing implicit and without implicit. So writing here x squared plus y4 minus z cubed. This is a problem. Z cubed plus 3xy squared equals to 8. We need to find this time random things. When I say random things, I mean I need different kind of partial derivative, dz over dx. And I also need to find dz over dy. Okay, So now we're going to be using implicit function a little bit different, right? Earlier we used in a different way. I'm going to be using right now in a little bit different way. Right, I first thing I need to do the common step. Common step, I need a function. This is my function. I need to bring 8 on the other side, so I can write my function this way. Y4 minus z cubed and plus 3xy squared minus 8 equals to 0. Now I'm going to be finding 3 partial derivative, right? But before I do the 3 partial derivative, I need to write 2 things. I'm going to be writing like this. I need to calculate these 2 things. And yeah. And I'm going to be writing according to implicit function. I'm going to be writing because of implicit function as per implicit function theorem. And that's a little bit tricky part. How can I write this as per function? So I'm going to be writing like, I can say that this is also be written zx. Remember the function we divided by function? We're writing like this, so we can call this as function x, right? The same thing I can say dz over dx, which is we need to determine in the question. I can write zx. Okay. But here the part is that which you have to remember. According to implicit function, I can write whatever the denominator, I can write in the numerator, and whatever in the numerator, I can write in the denominator. Since I flip-flop, I have to use a minus sign, and that is my implicit function. That's how I used to write implicit function. I can write like this, df over dx and df over dc with minus sign. And this is how can I write? Same thing, I can write this one is zy. I can also write, since I can take it up, so I'm going to call minus f y over f z. I can also, expand this thing in writing in a traditional way when we used to write this df over dy and df over dc. And the reason we are always putting this minus sign here or minus sign here, because see, here is a y in the denominator and z in the numerator. I flip-flop them. That's why minus sign is coming. And is a part of the formula, so you don't have to worry about it. Okay, I'm going to leave this thing over here inside this red block so we can focus on other things. In this problem now, I need to find out 3 things. I need to find fx, I need to find fy, and I need to find fz. So it's pretty simple. I can go to the for function and then take the partial derivative with respect to x, y, and z separately. Take the first one. If I take the partial derivative of this function with respect to x, is going to be 2x plus 3y. Right? Everything else becomes 0 here, just to make sure this is z cubed. Right? So 2x plus 3x or 3y squared. This is my answer. If I take with respect to y, so first term will be 0, right? First term will be 0. And then 4y cubed, first term will be 0, x constant have derivative is 0, plus 4y cubed, this constant is 0, z cube is 0, because the c cube considered as a constant, and then plus y, so it's going to be 6xy. Right? If I go to take the function and take the derivative with respect to z, so the x squared is z, y4 is 0, x squared is 0, y4 is 0, minus minus 3z squared. And the rest of the minus it is also becomes 0 here. So that is my function. So really I have three cases here. This guy here, this guy here, this guy here. I'm going to take one by one and substitute into my given function. So in this case, if I go here, I can write like that. This is fx given here, so it's going to be minus from the function, and 2x plus 3y squared divided by minus from dz fz, the minus 3z, so minus 3z squared. This minus cancelling out, and the answer will be 2x plus 3y squared or 3z squared. Same thing, I can substitute the values here. It's going to be minus 4y cubed plus 6xy. This minus comes from the formula, divided by minus 3z squared. This minus and this minus cancelling out each other, and the answer will be okay. Looking at another problem. Need to find, this time is given okay. What I'm going to do, I'm going to do pretty much same steps. It's like a little bit different function. Other than that, it's much simpler than the previous one. So I can just make my xy cube plus x squared z squared minus 6 equals to 0. I need to find three things here: fx, fy, fz. Fx means I'm going to take the derivative with respect to x, so it's going to be, here it's going to be 1 y cubed plus 2x and z squared plus 0. 6 derivative will be 0. We can take the y, and then we can take a look into that again one more time. This one is equal to, with respect to y is going to be x 3y squared, and with respect to, and that's it. Yeah, that's it, and everything becomes 0. Fz is equal to everything. First one, x y cube is 0, x squared, and then 2z, and then 6 derivative becomes 0. Okay, so let's to rewrite them one more time so it's a little bit better way, so it's not looking awkward. It's going to be y cube plus 2x z squared. This one becomes 3 xy squared, and this fz equals to 2x squared z. Okay, I have all three numbers. This one, this one, this one. I'm going to be just substituting into my implicit function. Implicit function of d z over dx, I can simply say it's minus. This is going to go in the numerator, right? But before than that, I can also write this one, this function. I can also write zx, right? Z with respect to x, and take the derivative, I can write zx. And according to implicit function, this one is equal to minus x gonna go in the numerator. So fx over fg. Same thing if I want to calculate dz over dy, dz over dy, and I can write it's going to be zy, and according to implicit function I can write like this, y over fz. I substitute the values, fx, so fx will be y cube with minus sign, y cube plus 2xz squared, and fz is going to be 2x squared minus fy is given here 3xy squared, and fz is given 2x squared z. Can I simplify this further? This one, there's not much you can do here. Yeah, there's not much you can do, so I just leave it here. The other one I cannot, maybe I can just canceling out x and x squared, that's it. So equals to minus 3y squared over 2x. So this is my first answer. That is my second answer. Let's take a look at another problem. Here the function is giving x squared minus xy plus y squared minus x plus y equals to 0. And I need to only calculate here is find dy or dx. Since I have only two variables, maybe I can write like this, dy over dx. Okay, let's solve it. I want to be calculating dy over dx. I can also write this, my function with respect to, my function with respect to x. Okay, and according to implicit function, I can write fx over fy. That is my function or my formula pretty much. Need to calculate f, x, and I need to calculate fy. This one I'm going to take it, so it's going to be respect to x, 2x minus y minus 1 minus x minus y minus 1 pretty much. Yep. This one equals to minus y minus x, minus x plus 2y and then plus 1. I'm going to take into this equation, and I'm going to write dy over dx equals to minus fx over minus fy, and minus, I can write, substitute the value, 2x minus y minus 1, then minus x plus 2y plus 1. I mean, I can do one thing, I can just multiply the numerator or denominator with this minus sign. So I can just take this minus sign and multiply the whole numerator, so it can be gone. And do not touch my denominator. I can just rearrange the denominator. I'm going to make this 2y on the other side, 2y minus x plus 1, and then I'm going to multiply this minus sign throughout this whole numerator. So it's going to be this y minus to minus minus is going to be y with plus, then minus 2x, then plus 1. I don't think so. We can solve it further, and this is our answer. Maybe you can take factor if they allow you to make the factor, you can solve it, but it's not necessary at this point. So that is my answer. Okay, I hope this explained to you what are the implicit function in detail. We did a lot of examples. Thank you for watching Knowledge Academy. Please subscribe my channel.